For those of you that just came in, happy Friday. You missed the Friday song, our weekly Friday song. I had someone in, those are my juniors, but someone in my third period saying, Mister, can we change the Friday song? And a whole bunch of kids were like, no, that's our classic Friday song. It's so cringy and we like it. So somebody wanted to change. I said, okay, if you want to change it to another Friday song, that's fine, but let me know. Maybe we'll have a Friday playlist with a bunch of songs that have Friday in it. But I think the couple of songs I'm thinking of, I don't think we can play because they need to be the edited version, right? Okay, so let's go over this warm-up. What is the measurement of the missing angle? So this angle right here. Oh, come on. This angle right here. What is the measurement of that missing angle? Somebody said 42 in the chat. Anybody else have a guess? Or do you agree with that? Someone else said 42. Anything else? Anyone think it's something different, or anyone agree? Or does anyone want to? Tell me why. Okay. Now, let me explain this to you because I wanted to explain this to you. So many of you think the answer is hey, I got the answer right. That's it. I'm done. I'm good at math because I can get the answers right. And that's okay, but you got to think of math like a sandwich. So let me tell you what I'm talking about. So we have the question. That's one bread. And then we have the answer at the end. That's the other bread. Here's my answer. Right? And what's in between the question and the answer? That's what makes the sandwich. That's all your stuff inside, right? All the stuff inside the sandwich, right? And this is the most important. The bread is still important. When you have a sandwich, yes, bread is still important. So yes, the question is important and the answer is important. I'm not saying it's not important, but the most important stuff is what's in between the question and the answer. What's inside that sandwich? Now, some people told me in first period, hey, mister, and I've been here, sometimes I have bread sandwiches, right? And I've been there. Hey, Mom, what do we have to eat? We just have bread. We don't have any lunch meat or cheese or anything? No. Okay. So we have maybe put some mayo in there and a pickle. And then you have it, not much in between, not much inside your sandwich, right? I've been there. And yes, there are questions like that in math where the question and the answer are just like that and there's not much in between. Maybe a pickle and some mayo or something, mustard. So I understand there are, but most questions are like this. There's a whole bunch of stuff in the middle and there's stuff you need to know. So that's what I want to know. Tell me why. Right? This is 42 degrees, but how do you know that? How do you know that? Give me the meat of the sandwich. Because a lot of you are just, hey, mister, I gave you the answer. That's it. I got the answer right. I'm good. No, I need to know how you got there. So how? How do we know it's 42 degrees? We need to know some facts. We need to know some facts in order to get that. So what's a fact we need to know? Fact. Beats, Bears, Battlestar Galactica. So what's a fact I need to know that this is 42 degrees? That we know this is a right triangle and this means 90 degrees. Good. And then, so you're right. So this is 48 degrees. And this in the corner is 90 degrees. That little square in the corner means right angle, means 90 degrees. Okay. So what fact do we know that leads us to, okay, if this is 90 and this is 48, then that has to be 42. Tell me why. What's the fact that leads me to know that, hey, that's 42 for sure? I add 90 plus 48. Okay, why would I do that? What's the fact I need to know? Come on, guys, there's a lot of people in here. There's a fact about triangles that you know that lets us know for sure that that's 42. This person in the chat's telling me add 90 plus 48. Good. Why would I do that, though? I get 138. What does that have to do with 42? What do you mean the triangle is 180? Give me more details. You're on the right path. So 180 minus 1. Why would I do 180 minus 138? What fact do I know that tells me I can do this? What's the fact? You guys haven't given me a complete sentence on what the fact is. You're completely right. 90 plus 48 is 138. And 180 minus 38 is 42. But why can I do that? What's 180 minus 138? Why would I do that? Because the fact is all angles of a triangle, of any triangle, add up to 180 degrees. I said that, mister, in the chat. No, you said the triangle is 180. That's an incomplete sentence. Another person said all triangles equal 180. That's an incomplete sentence. All angles of any triangle add up to 180 degrees. So that's the fact. There you go. That's part of the sandwich, right? So we need to know that any triangle, all the angles equal 180. And we know this little guy right here, that square means 90 degrees. So if that's 90 and that's 48, that's 138. And 180 minus 138 is 42. Another way we can look at this, and this is what I want you to do, another way we can look at this is if we know this fact, that all angles of any triangle add up to 180 degrees, that means if this is 90, isn't 90 degrees half of 180? So that means half of the angle measures are right here. That means these two angles right here, they have to add up to 90 degrees. And what's that called? When two angles add up to 90 degrees, what is that called? When two angles add up to 90 degrees, they are blank angles. What kind of angles? See, this is that whole understanding, right? This is that whole sandwich part. Yes, we got 42, but that wasn't enough. That's great that you know that this is 42 degrees. That's wonderful. But that's not the whole thing. Yes, complementary angles. So that means, so this is where we start thinking and start looking deeper into what's going on, right? If this is 90 degrees, that means these two have to add up to 90 degrees. That means they are complementary angles, right? Because they add up to 90 degrees. Right? And another word that we can see here is these two angles are less than 90 degrees. So both of these are the acute angles. These are acute angles. And so we can write another fact. The acute angles, those are the ones that aren't the right angle. And we know they're acute because they can't be 90 degrees. You can't have two 90-degree angles in a triangle because that's 180 already. And all three have to add up to 180. So those two angles that aren't the right angle are called your acute angles. So the acute angles of any right triangle are complementary. Complementary, as some people say. So there's another fact. Maybe you didn't know this, but now you do. Okay, so the two angles, these two angles that aren't the 90-degree ones, those are called acute angles. And remember, acute just means less than 90 degrees. And of course they have to be less because that can't be 90 and that can't be 90. And it can't be more than 90 because that's already 90. And they all three have to add up to 180. So we know these two add up to give you 90. So they're complementary. And these are the two acute angles. So there's a fact. The acute angles of any right triangle are complementary. Write these down, and then we're going to start our new notes. So you see what I mean about going a little deeper, just knowing the answer is not enough. You got to understand why. Then you got to understand pieces of what's going on, right? Pieces of what's going on. So there's a right triangle. The other two should add up to 90. Ooh, those are both acute angles. And two angles that add up to 90 are complementary. So the acute angles of any right triangle are complementary. And the other fact is something you did know. All angles of any triangle add up to 180 degrees. All right, any questions? Any questions? All right, good. So here we go. Happy Friday, April 16th. today's objectives are the same as yesterday's. We're going to understand what the trigonometric ratio. Some of you are like, what? That's a long word. Okay, just say trig. We say trig for short. The trig ratios or trigonometric ratios. We got to understand what they are, and I'm going to explain that to you. Again, you may get confused, but I'm just telling you, ratios, like we talked about yesterday, is just a fraction. When I ask you to find a ratio, I ask you to find a fraction, right? The first one goes on top and something goes on the bottom. You have to know the particular order, what goes on top, what goes on bottom. So when I ask you for these trig ratios, I'm just asking you for a fraction. Okay? And that's all you're looking for. Now, some of you may get confused on how to find that, and we'll talk about that because there is vocabulary tied to it, but just understand, when I ask you to find the sine, the cosine, the tangent, those are the trig ratios. I'm just asking you for a fraction. Okay, and you got to look at the triangle and figure out what you have to put in that fraction. That's it. Really simple. And then once you know how to find or set up the equations by finding the sine, cosine, and tangent, you're going to use those trig ratios to find side lengths. So you're going to see a triangle, and it's going to be a side that I want to know, and we're going to find it using these trig ratios that I'm going to teach you. Now, are we going to finish the lesson today? The answer is no. So you see how this says due on Friday? I'm going to change the due date, so it's probably going to be due on Tuesday. Just because we're not going to finish the lesson today. But we're going to start it today. We're going to continue on Monday. And then Tuesday we should be finished up. And then Tuesday night you'll turn in that homework. Okay. And again, if you're going to need more time than that, that's fine. Because I know a lot of you are going to be working on those 3 assignments that you didn't turn in before this weekend. Because after this weekend, I'm not going to accept them anymore. Okay. All right. So let's take out our notes. Take out our intro to trigonometry notes. And if you don't know where to find them, if you weren't paying attention, now I know some of you have sent me this and I appreciate your honesty. Okay. But you got to go one step after, because I had a few people say, Mister, I'm going to be honest with you. Sometimes I turn on your class and I don't even pay attention. Sometimes I zone out. Sometimes I don't even have the volume up. I appreciate that honesty. Ain't mad at you. Thank you for being honest. Okay. You have your reasons for doing what you do. But then there is a second step to that. You can't just admit your wrongs, right? That's step one. You got to go to the next step. Some of you like to admit the bad things you do, but then you stop there. You're like, yeah, I do this and I do that. I'm like, wow, thank you for being honest. But then you stop there and you don't do anything after that. There's kind of next steps if you want to improve, right? So you admit you did something wrong, which is fine. The next step is try to stop that. Try not to do that, okay? So those of you that were zoning out, and some of you told me you were yesterday, go to Schoology, log in, just like we always do. And those of you that can't get into Schoology, please let me know. Some of you were telling me yesterday that you haven't been able to get into Schoology at all. I gave you the website. I'll put it in again. This is where you go to Schoology if your app isn't working or you never set it up correctly. Just go here. Just go here, and then you can go to Schoology on, see right here, on the internet. No, not here. Oh, come on. See the web address up on the top? That's exactly where I'm at. So then you go to our course, period 14, and then week 13. And there are the notes. There's the notes, there's a note solution, and then there's the homework that says it's due tonight. I will change that due date because I'm not going to be able to finish the lesson. And there's our notes. And there's our note solution. So those of you that miss taking notes or zone out, you can always come over here and check out the work on your notes. Okay, so here is the notes, Intro to Trigonometry. Sounds like a difficult word, is not very difficult. So what is trigonometry? It's very simply the study of triangle measurements. And when I'm talking about sides and angles. That's it. That's all trigonometry is. It's the study of triangle measurements. Now, some of you may say, no, mister, I have a cousin or a brother or a sister or mom, dad, aunt, uncle. They told me trigonometry is the study of right triangles. They're not wrong. Trigonometry does look at a lot of right triangles, and it has a lot to do with right triangles. That's where it begins. But they extend all the stuff from right triangles to any triangle. Right? We have the law of cosines, the law of sines, which is helping with any triangle. So yeah, so it is mostly right triangles. So you are correct in that. Some of you that have heard that. So yes, it is mostly right triangles, but it is just the study of triangle measurements. And it does begin with right triangles, which is what we're going to do. Okay? And so if we look here, let's start looking at the trig ratios. So I know it says trigonometric, but I mean, you can just say trig ratios. That's how everyone else says it, but that's the whole word. So here is a triangle. Here is a right triangle. I have angle A, B, C, and I have sides A, B, C. Okay. Remember the angles, the points right here. The angles are capital letters and the sides are lowercase letters. Okay. Now here are the three trig ratios: sine, cosine, and tangent. Sine, we just say sin. Cosine, we just say cos. And tangent, we just say tan. Now, when we find these ratios, we're just looking for a fraction. Now, each one has a different fraction they're looking for. So let's start with sine. So when I'm asking for sine, I'm asking for a fraction. Okay? And the fraction I'm asking for is the ratio of the opposite side to the hypotenuse. So my fraction that I'm making is opposite side or opposite leg over the hypotenuse. And then some of you are saying, wait a second, mister, opposite of what? What do you mean opposite? Ah, there you go. So when I look at this angle, this triangle, this side is the hypotenuse, right? That's the hypotenuse. And these are the legs. So when I'm finding sine, I know the hypotenuse is, but what leg do I put on top, mister? Do I put this one on top or do I put this one on top? What do you mean opposite side? Well, what I mean is you have to have an angle that you're talking about. So when I say sine, I have to say the sine of an angle because you have to know what angle you're talking about. So for instance, if I say the sine of angle A equals, and then I have a fraction, now I'm going to put the opposite side over the hypotenuse. Well, what do you mean by opposite side, mister? Well, if I look at angle A, and here's angle A, the opposite side is the side or the leg that's way over here on the other side. That's not even touching A. Okay, so when I'm telling you the sine of A, that means I start with this angle. That means I kind of think of yourself standing at this angle. And I want to find the ratio. Remember, if you're finding the sine of something, you're finding a ratio. So I'm standing right here. So this just tells you where you're standing. You see how I say the sine of A? Well, this is the angle where I'm standing at. Just imagine yourself standing right there. Let's draw a little U. You're standing right there. So which side is opposite of U? Well, it's that side way over here. And which side is the hypotenuse? Oh, that one, C. So if I'm finding the sine of A, it's the opposite side, which is right here, which is A, over the hypotenuse, which is right here, which is C. Okay. Now, I know it's a little difficult because these aren't numbers, and you're looking at this and going, okay, A over C. Yeah, so whatever numbers right here would go on top, and whatever numbers right here would go on bottom. That's how I find the sine of an angle. But mister. Yes, student. What if I was standing at B? Oh, okay. So you mean what if you were standing right here? Yeah. Okay, so that means I'm finding the sine of B. Okay, so if I'm standing right there, I'm finding the sine of B, which is what? It's still opposite over hypotenuse. The sine is always opposite over hypotenuse. So now, if I'm standing here, I have a different opposite. This is not the opposite. This is right next to me. This is right next to me. So that's not it. So the opposite side is way over here. Way over here. So the opposite side is B. And the hypotenuse is still the hypotenuse. That doesn't change. The hypotenuse is still C. So it all depends where you're standing. It all depends what we're taking the sine of it. Whatever angle follows the word sine. Whatever angle follows the word sine. That's where you're standing, and that's how you figure out what the opposite is. So those of you that are saying, what do you mean by opposite side, mister? Opposite from where you're standing. How do you know where you're standing? This tells you where you're standing. Sine of A, so I'm standing at A. Sine of B, so I'm standing at B. And then you just write your fraction. You write your ratio based on where you're standing. So let's write that down over here. So the sine of A, according to that, will be A over C. And the sine of B would be B over C. Because sine just tells me the sine ratio is just the opposite side over the hypotenuse. Okay, I'll give you a second to write that down. If you want me to zoom in on any part, it's going to make more sense when we come down here. When we come down here and we do a problem like this, right? Like if I'm here and I say, okay, here's A. What's the sine of A? Well, if I'm standing, and you guys can imagine, what's the sine of A? Well, that's going to be a fraction, right? Because sine is a ratio. And so if I'm standing right here, the sine is opposite over hypotenuse. So opposite. So that if I'm standing here, the opposite is way over here, which is 5. And the hypotenuse is just the hypotenuse. The hypotenuse is right here, 13. And there you go. The sine of A is 5 over 13. That's it. That's it. You just have to write a ratio. So right here, we're just doing it with letters, so that way you can get an idea of what's going on. We're just doing it with the letters. That's what we do in math. So I'll give you a minute to copy that down. Then we'll talk about cosine. All right, so let's talk about cosine. So cosine, what is cosine? Cosine is just another ratio. But cosine has a ratio of adjacent. Adjacent over the hypotenuse. So that ratio gets the adjacent side. What the heck's adjacent? I'll explain that in a second. The adjacent side over the hypotenuse. That is the ratio of cosine. Okay, and what does adjacent mean? What does adjacent mean? Does anyone know what adjacent means? If you don't know, it's okay. But if the opposite side was the one way over there, what do you think adjacent means? The adjacent side. Or the adjacent leg, right? Oops. That's not the highlighter. The adjacent leg. Close or near. Very good. It means next to. Right? Next to. If you are adjacent to somebody, you need to stay 6 feet away from them for social distancing. So cosine, you can't just say cosine. You got to say cosine of what? Because you got to know where you're standing, right? Because we have two angles that we can be at. We can be here or here. We're not going to stand here because that's the right angle. We're only going to stand on one of the acute angles. So you can only find sine and cosine of this picture from the acute angles. So what if I said, what's the cosine of A? What's the cosine of A? Okay, so A, this is just telling me I'm standing at A. And you can draw a little U. And so now, if I want the cosine of A, I need the adjacent side, adjacent leg over the hypotenuse. Okay, so that means cosine of A is, what's the adjacent leg? Well, if I'm standing right here, the adjacent leg is not this one over here because that's way over here. That's on the opposite side. That's the opposite side. The adjacent side, the adjacent leg would be right here, B. So that's what I put on top, B. And then the hypotenuse is just the hypotenuse. That doesn't change. The hypotenuse is always the hypotenuse, and that's just C. So B over C. Okay, and then if I want to do the cosine of this angle, well, mister, what if I'm standing over here? Okay, if you're standing over here, that's the cosine of B, right? Because now I'm standing here. And so the cosine of B is the adjacent side. So it's still the adjacent side. Well, which one's the adjacent leg, mister? This one right here. Mister, why isn't this the adjacent leg? Because that's the hypotenuse. You don't choose the hypotenuse. It says the adjacent leg. These are the legs. Oh, yes. The adjacent one means the one next to it, the leg next to it. Not this one, because that's a hypotenuse. Hypotenuse is not a leg. And so the adjacent one is here, so I'd put A on the top. And then the hypotenuse is the denominator, so I put that on the bottom. A over C. So if you're confused about A over B and B, you don't have to memorize this. I'm just showing you how I found it. All you have to know is when I say sine of an angle, I want opposite leg. And I keep putting side. I'll put leg to make your life a lot easier. Opposite leg over the hypotenuse. Okay? And when I talk about cosine, I'm talking about adjacent leg over the hypotenuse. That's all you need to know. That's the ratio for cosine. That's the ratio for sine. And on Monday, I'll tell you what tangent is, and then I'll tell you how SOHCAHTOA can help you remember these ratios, right? Because this is all ratios. So sine is opposite leg over hypotenuse. Cosine is adjacent leg over hypotenuse. And just a little sneak preview before we go. Tangent is, anyone want to guess what tangent is? No, nobody wants to guess? Okay, fine. That's fine. All right, so we'll talk about that on Monday. Homework says it's due tonight. I will change the due date because we did not finish. We weren't even close to finishing the notes because we have to go over what sine, cosine, and tangent look like with real triangles, with real numbers, not just letters, because I know some of you are looking at these letters and going, I'm confused. I don't get this. Okay, if you're looking at all these letters and B over C and A over C and that's confusing you, that's fine. All you got to remember is here, sine means opposite leg over hypotenuse. Cosine means adjacent leg over hypotenuse. Okay, if you want to ignore this stuff over here, if you want to ignore this, that's fine. This was just the examples with letters. If that's confusing you, that's fine. All I want you to remember then is sine is a ratio. Sine is a ratio. And this is the ratio. Opposite leg over hypotenuse. Cosine is another ratio of a triangle. And it's adjacent leg over hypotenuse. Okay. All right, guys. Have a great Friday. Have a great rest of your weekend. I will see you all on Monday. And take care, everyone. Ms. Rivas, thank you for your help. You too. Thank you. Take care, everybody. Bye.